Remember the Artemis launch? A monumental achievement, a statement that humanity really is standing on the shoulders of giants when it comes to astrophysics and science. I watched the Artemis launch wondering, how did physics get us to strapping people to exploding barrels? So I thought, let's look back on the timeline of physicists' contributions that started it all. We'll start with Nicholas Copernicus. He proposed a heliocentric model, stating that the Earth isn't in the center of the solar system, but that the Sun is. Later on, Galileo Galilei found out that objects with different weights still fell at the same rate. He also describes inertia, laying the groundwork for a certain someone's laws of motion. With the telescope he made himself, Galileo observed Jupiter's 4 biggest moons and the rings around Saturn, supporting the heliocentric model. Johannes Kepler improves Copernicus' theory with his 3 laws of planetary motion, calculating that planets move in elliptical orbits. Isaac Newton, the mad lad who discovered calculus, sat under a tree and wondered why an apple fell down and not sideways. He writes an equation that for the most part describes gravity, and developed his laws of motion. After Newton, we get a strange part of the timeline where new discoveries don't exactly build off of existing discoveries, but rather branch out into their own separate fields in physics. They're still relevant in today's technology. John Dalton proposes the existence of indivisible atoms, with them rearranging to make different substances. Charles Augustin de Coulomb describes the forces between charges, an equation that looks eerily similar to one of Newton's equations. Thomas Young, using his double slit, finds that light can behave like a wave because it amplifies and cancels out itself, challenging the view of light as a particle. Michael Faraday finds a relationship between magnetism and electricity with a coiled wire, making his law of induction. James Clerk builds on that by combining electricity, magnetism, and optics into one concept, a theory of electromagnetic radiation, where magnetic and electric waves oscillate together at the speed of light. J.J. Thomson discovers the electron when deflecting negative charges in a glass tube, which improved the model of the atom with the plum pudding model. Michelson and Morley experimented with detecting the Earth's movement, but then they accidentally found that light moves at the same speed regardless of motion relative to it, foreshadowing a certain someone's relative revelation. Rutherford shot positively charged particles at gold foil, finding out that atoms are mostly empty space, with the nucleus in the center, refining the model of the atom even further. Now we have reached the realm of quantum physics, starting with Max Planck's law of blackbody radiation and discovery of the quantum, which is the smallest unit of energy that isn't continuous. Niels Bohr improves the model of the atom with electrons orbiting the nucleus and energy levels, which better illustrates ions and isotopes. It's a model that's still acceptable today. Albert Einstein did so much that I can't cram it all into this video, but long story short, mass equals energy, nothing can travel faster than light, and light has a particle-wave duality. He's most well known for improving Newton's theory of gravity, describing it as the fabric of space-time bending and therefore explaining time dilation. Erwin Schrödinger's equation describes a wave function over time. He improved the model of the atom by describing them as these probability clouds. His dead-alive cat thought experiment describes quantum superposition and how it collapses to one state once observed. Finally, Vera Rubin proposes the existence of dark matter, Tim Berners-Lee invents the World Wide Web, and in 2012 the Higgs boson is discovered from smashing particles together, implying a field where subatomic particles have mass. Bringing us all the way back to... The craziest part is that this timeline is still going. We're still doing science, asking questions, testing theories. Maybe we'll marry quantum physics with general relativity for a possible field theory of everything. Until then, as Artemis has showed us, the sky isn't really the limit.